Yes, sir.
Good. So let me take 230. I can share the screen first. Okay. Are you able to see the screen?
Yes, sir. Visible.
Yes, visible.
Mhm.
Okay, okay. Good. Just a minute. Okay. So the screen is visible now, correct?
Yes, sir.
Okay. So we can start new chapters, that is dynamics, part of the kinematics of particle. So we are not dealing with the force that is causing the movement. Only the relationship between say displacement or velocity or accelerations. Now today, first one we will consider normal and tangential component or coordinate. We call n and t coordinate. So this is one path. At any instant, we can have we can have tangential directions and also normal directions. And this angle is 90 degree, denoted by this symbol. It is 90 degree. So normal and tangential components. Say for example, we have one particle which is moving along this path. This is the path. The particle will move. This is the direction of movement of the particle. Take one point A, another point B, another point C on the trajectory of the particle. Now at point A, you can draw one normal and you can draw one tangent. At B, you can draw one tangent and one normal. At C, one tangent and one normal. Tangent and normal. Tangent, normal. Tangent, normal. So you can have a look that tangent is always tangential to the path, but normal sometimes it is towards this, sometimes it is this, sometimes it is towards this. So always it is towards the center of curvature. Now curvature, if it is like this, it will be like this. If curvature is like this, it will be like this. If curvature is like this, then it will be like this. Normal one towards the center of curvature. Now maybe we'll consider once again the path of the particle like this, and it is moving from bottom to top down to upward directions, and this is the 2D problem, simple problem, 2D problem. And you consider any two points A and B, they are very sorry, A or A prime, A and A prime, they are located with a very small distance, curvature arc ds. There the distance is very small, and these two, this curvature a prime, this arc is causing one radius of curvature rho with respect to the center C, center of the curvature, and it is making angle d beta. This is the angle that is very small value. And if somebody want to draw one tangent at A, this is the tangent, and we have this velocity v that is along the tangent, and at A prime, tangent say t prime, here t prime, and velocity is v prime along this tangent. So if somebody want to draw a normal also here, somebody can have En prime, that is the normal directions, or maybe N prime. Here this Et is a unit vector. En is also unit vector along tangent and normal. So here Et prime and here En prime. So what I told, there are 2 points we can consider along the path. They are very close to each other. We can draw the tangent and normal T and N for A, similar for A prime. Now let's these 2 normals are meeting at point C. C is the radius of center of curvature, and let's have rho is constant value of rho as the radius of curvature, which is making this two normal making angle d beta. So along T, unit normal Et prime, along normal, unit normal is En. Here along tangent T prime, it is Et prime and it is En prime. Velocity v, this is v prime. Velocity v, it is v prime. Now somebody want to draw these two velocity in vectorial form. So let's have from this point, velocity is like this. Up to this, it is the velocity v. And here, this is very small distance. I can have same point and I can draw v prime velocity. Now v and v prime will create one resultant increase of velocity dv. Now whatever this dv resultant of v and v prime, along that directions accelerations will act. This is we call acceleration or a total along that directions. Which directions? Resultant of v and v prime. Now somebody can have this velocity v and you can decompose along tangential directions and along normal directions. So this is dv, this is along tangential t directions, this is dvt, and this one is along normal directions. It is dvn. Wherever we have dvn, delta V, so dV component in normal directions will create normal accelerations, and along tangential component will create tangential accelerations. Here it is very small, so it is not been shown, but little bit here some more value will be there, like this. Why? To get this rectangle. Okay, rectangular shape. Have you understand up to this, or should I repeat this? Have you understood this, or should I repeat this? Anyone
Yes,
can
I
say.
understood.
Yeah. Now, what we told, we have two unit vector ET and EN. So we can have along this tangential directions ET unit vector, and this is ET prime, and that is making angle D beta. Now this difference, so there are two unit vector, they are changing also sign, directions. They are changing the directions, ET and ET prime, and it is having some angle D beta. Beta is very small, beta is in radian. Then the difference, vectorial difference between ET and ET prime, that is DET. That is DET, vectorial difference between these two. One is ET, magnitude wise it is 1, other is ET prime, magnitude wise it is 1. The vectorial difference is DET, and DET is acting along the normal directions. You just try to understand, if it is, say this is 1, this is also 1, this is the ET, 1 value, this is also 1 value, then this is the DET, and that is along the tangent normal directions. Along the normal direction. So DET is acting along the normal direction. Is this clear? DET is acting along the normal directions. Should I repeat this? DET is acting along the normal directions. Should I repeat?
Yes, sir.
Sir, please repeat, sir.
Yes, yes. So you understood here that here this is AN, AT or the tangential directions, it is AT. Now you consider two normal unit vector ET and ET prime. So ET is supposed to be along this, and ET prime supposed to be along this line, is not it? Unit vector definition. As I told here, this is ET. Let me change the color. I told here this is ET, this is ET prime. Now this ET and ET prime, these 2 points are very close. I have drawn here, this is ET and this is ET prime. Vectorically, this is the resultant, DET. ET prime, ET and ET prime minus ET, vectorically it is DET. That is the difference between two unit vector due to change in directions. And that is acting along this normal directions, Is this clear?
Yes, sir.
Okay. Now we will utilize this. We will utilize this discussions to get basically this acceleration, total accelerations. Here I told it has two components. One is tangential, one is normal, and this normal accelerations, that is related to v square by rho, that you know. I want to prove that. So to do that, what I will write here, A prime, this length, A prime, this length basically ds, just length. Okay. Now we know this expression. Maybe I'll divide this into 3 parts. We know this A is equal to r theta. theta is in radian and it is small value. Similar way, we can write ds, s equal to basically ds r theta, rho d beta, rho d beta. Beta is small, d beta is very small, and beta is in radian. Now, velocity magnitude. I'll write this is the velocity magnitude and this is the vector. That notation I want to write. So, velocity is ds dt. So, rho d beta dt. So, let's consider rho here, separate out. So, d beta dt or velocity equal to rho beta dot. See this dot, sorry, double dot has to, okay, one dot. So this dot means rate of change with respect to time. Rate of change of some value with respect to time. So beta dot means rate of change of beta with respect to time. Or somebody can write beta dot equal to v by rho. This is one observation. Now, as this velocity v, vectorically it is magnitude multiplied by, what is this? Velocity is acting in which directions? Velocity v. This velocity v is acting in which direction? Tangential, correct?
Initial.
Yes, sir.
Yes, sir.
So it is et. Now this acceleration will be d of this equal to t of dt v this. So et, this hat is representing directions. That means v et dot plus v dot et. Up to this you understood. This is et dot means your rate of change of et. It is changing due to the curvature or beta. Okay, change in beta or change in directions as the curvature is concerned. Now, on the other hand, magnitude wise, this equal to this equal to 1, as this is unit vector. So, somebody can write from here this det s equal to r theta, det equal to et multiplied by d beta. So, this det equal to et multiplied by d beta. Et equal to 1 multiplied by d beta, or det equal to d beta, magnitude wise. Now, this det, this one, it is d beta, and it is det is acting in which directions?
Normal.
Normal.
Sir, normal.
Yes. So I can write this. Direction also I have given there. If it is so, then somebody can write this also, det dt equal to d beta dt en, and this d beta dt equal to beta dot multiplied by en, beta dot multiplied by en. Now, let me change color. So, what we got here from this? Acceleration equal to v, okay, dt, this is nothing but et dot. This one. Et dot equal to beta dot En. So we'll write here V beta dot En plus V dot Et. Now this part is basically An and this part is basically At. This is the An part, this is the At part. So what is At? At equal to V dot or S double dot, or somebody can write d of dt of V dot we got before. Just a minute. Here V value we got here. V, this is V dot d dt of beta rho beta dot equal to rho beta double dot plus rho dot beta dot. This is At. Sometimes we may require to use this type of expression. We know this is tangential acceleration is nothing but ds dt, but we can have this type of form also when it is in a curvilinear motion and in nt coordinate system. Then what is At? At is V beta dot equal to V beta dot equal to V by rho, okay, multiplied by V by rho. So V square by rho. One way we can write, or somebody can write V equal to rho beta. So rho beta dot, sorry, rho beta dot square by rho, that is rho beta dot whole square, or maybe somebody can write some other format also, don't worry. So only we are interested mainly here two things. Let me change the color once again. That is At equal to V dot. If you require, you can have any time these formulations ready for you. An equal to V square by rho. So this way we can have the idea for tangential acceleration and normal acceleration formula. So in 10+2 standard, many times you just remember this, but we can prove at any time. At equal to this, An equal to this. Now, what will be the physical significance for this? Physical interpolations of this. Let me explain for your better understanding. Just a minute. So what we'll do? Let's have, this is I have already done. Yeah. Let's you have this here. It is V. Here it is V. This is this to this. It is dV. This is V and this to this dV. Then this one, this distance. If somebody write An magnitude wise, this An will be this one. An will be not An. Let it be Vn. dVn. This dVn first. This dVn will be magnitude wise. This dVn will be V. Here it is dV. S equal to r theta. dV equal to V dV. And An will be magnitude of dV and dt. That is V d beta dt. So V beta dot. An. That one also we have shown here. somewhere. Wait. Sorry, this was n. You should tell this. This was n. Sorry, I did the mistake. So an was this. An was this. So this an was v beta dot. From this one also we can get that relationship. This an is v beta dot. That is the geometric interpretations. If I want to do the geometric interpretations from this figure also we can say that dvn is acting along that direction, that is v multiplied by dv magnitude wise, and an will be dvn dt, and that will be v beta dot. Should I explain once again? That's all. So only one thing I should include, that so what we understand that yes, so this is the A total. It is having two parts. One is AT and AN. AT is always acting tangential to the path along the velocity, and normal is toward the center. Now, by seeing this acceleration vector, if I use the acceleration vector, means total acceleration vector, so this, and this movement is from this to this path it will follow. So this acceleration basically has two components. One is tangential, one is normal. One is tangential, other is normal. You see, tangential, other is normal. Normal, tangential. Here it is tangential, normal 0. It is tangential, this is normal. This is tangential, this is normal. I want to decompose that. So normal will be based on the path, curvature. But you see here, if this is the acceleration, this is the tangential. So normal, this is the tangential. Normal, this is tangential. Normal, tangential. Normal, normal, tangential. Normal, tangential. You can see the particle is moving in the directions. The direction particle is moving. If it is increasing speed, that means we have accelerations. Then we are supposed to have this arrow, increasing directions along the path, increasing directions. But when it is speed decreasing, you can see in reverse directions, tangential component you can see. Tangential acceleration will be in reverse directions, not along the path. Got this point? So whatever total acceleration you have, you can decompose normal and tangential. Normal will be always normal to the along the normal to the curvature. But seeing the tangential, somebody can say whether it is speed increasing or decreasing. If it is increasing, then inclination will be the direction of the acceleration component, along tangential component will be towards the direction of the movement. Have you understood this point, or should I explain once again? 2 points.
Understood, sir.
Yeah. So I will be back here. Only thing is this one. What about this? Tangential, we understood. Normal one is v square by rho. If I ask you, can you prove this? After reading this.
Yes, sir.
After, yes, I
Yes,
think.
sir.
Yeah. Tell me. You can do, correct?
Yes, sir.
Okay.
Yes,
after
sir.
reading, yes, after reading the book, you can do. No problem. So now, whatever I told, this curvilinear motion. Now let's concentrate some special case from here itself. Some special case. Right here itself. Let me take different color. Which color? Okay. Say now rho. This rho, which was in this form, we can vary. Okay. Let's have rho equal to constant equal to say r, radius of a circle, and this beta we can replace by theta. This beta, t beta, we can replace by theta. Then what we are getting? Velocity v, this velocity equal to rho theta dot. Sorry, r theta dot. Okay, and theta dot also somebody in 10 plus 2 will write omega, correct? So it was r omega. R omega. And an equal to v square by rho, v square by r. Or maybe v square by r, or maybe somewhere it is been written this one r theta dot square. Okay, r theta dot square, or maybe v theta dot, and at equal to v dot equal to r theta dot. So this is the special case which is called circular motions. So in circular motion, what is happening? Go back, circular motions. Yes, for circular motions, a special case of the plane means 2D curvilinear motions, where radius of curvature rho becomes constant radius of r, that is radius of the circle, and angle beta is replaced by theta measured from any convenient radial reference, say OP. This is the O, this is the P. Okay, and velocity and accelerations components of a circular motion is, this is velocity, this is acceleration, tangent normal, this is the tangential. So what is happening there? This is theta, this is normal, this is tangent, this is n, this is at, this is the velocity, this is r. That's all. Is it clear up to this?
Yes, sir.
Yeah.
Yes, sir.
That means we have finished to this 2.5 article. Okay, and problem sheet 3. I will come to the problem sheet later. Just a minute. Now we have next chapters. That is the constant motions. So motion has been restricted using some constant, some sort of other means, such that movement will be regulated. Okay, say you have one shaft, another shaft, there should be some belt. Using the belt, you have to transfer from one shaft to other shaft. So that is also constant motions. When you have your watch, it is having 60 that hand of second, minute, and hour. They are also restricted by 1/60. That gear ratio they are maintaining 1/60. That way they are getting 1 hour 3600 seconds. So those also some sort of constant motions. Motions are being restricted by other means. Okay. Now let's consider. So this is the one example of pulley. You may have rope, you may have cable, and using that here also another set of examples, different pulleys. Okay. So we can hoist one heavy weight from one place to other place, and there are many other applications also. Now consider very simple one, this type of problems. So this first thing we should know, degree of freedom. What is degree of freedom? Number of equations, or
Number of independent ways a body can move.
very good. Or number of now degrees of freedom, it may not move. Number of minimum number required to specify the object in a system. Movement may not be there for static problem. Degrees of freedom is applicable for both static and dynamics. I want to modify your definitions you have given for dynamics. For static also it will be applicable, such that minimum number required to specify the position of any particle on object body in a system. Same definitions. Okay. How many degrees of freedom here we have? This problem, such that this can move along the horizontal one pulley, second pulley, and this is another weight, it will move also. How many degrees of freedom you can expect this problem? Yeah, tell me how many degrees of freedom this problem? Any input?
So two.
Two. Okay. Okay. I will tell you. This problem, if I fixed this y value, okay, if I fix this y value, how many configuration you might be having? Say fix y equal to say 20 centimeter. Then
Only one.
Sir, the A block can move right or left.
no, how if y is fixed? If y is
So
fixed,
only one possible call.
only one possible configurations. Understood? Even if you fix x value, then you cannot have y, and y will be fixed also. Basically, it is happening this way. It is degrees of freedom is one. Only one position is enough to specify the problems correctly. So, if you consider this length of the cable, this is the cable, we have to calculate the length of the cable. Okay, so L equal to x plus this one pi 2 pi.
Set
Yes, tell me.
2y plus b.
X plus R2 2 pi R2 by 4 plus 2y plus 2 pi R1 by 2 plus b. Is not it?
Yes, sir.
So this is constant. This is also constant. Pulley is fixed. R1, R2 is fixed. B is also constant. So it is basically x plus 2y plus some constant. Is not it? Now, if you want to do the derivative, it's a dl by dt. So L dot will be x dot plus 2y dot. Once again, to get the accelerations, L double dot equal to x double dot plus 2y dot. So it says that okay, one thing. So what is the L dot value? L dot length is constant, correct? So whatever L dot
Zero.
x dot plus 2y dot equal to 0 or x dot equal to minus 2y dot, or maybe this x dot is representing velocity here, va equal to minus 2 vb. It is vb, so it is vb, that is va, or maybe it is acceleration a and acceleration b. Then from second one you can get that acceleration a equal to minus 2 acceleration of b. That means this movement of a velocity is twice the velocity of v, due to in this expression you got 1 plus x plus 2y, that term. That way your pulley here is constraining the motions, it is restricted motions, and it is the relationship. Now somebody is given some value of a VA, VB, and remaining thing can calculate. And this is very simple problem. You can understand this problem very easily. Next, move to the next problem. This one. How many degrees of freedom we have? We have cable. This is the one cable. This is one cable. This is a second.
1 degree.
Okay, you consider this one. Maybe you fixed YA. You fixed YA. That means this is fixed. Now, can you move B, block B, or maybe this is C? Can you move? See, I have fixed here. Fixing here means this length is fixed. Okay, this length is fixed.
Sir, YD can't be changed here.
YD cannot be changed, yes.
Sir,
But
YD can be changed, sir. YD
B
and
can be
YC.
changed. Okay, B can be changed. Now if I fix B, then A can be changed.
Yes, sir.
That's why it
Yes,
is 2
sir.
degrees of freedom. Yeah, yeah. 2 degrees of freedom. It is 2 degrees of freedom. Okay. So this problem is basically 2 degrees of freedom. Now you can get, if you see, somebody can have this distance. This distance is fixed. Always this distance is fixed. Previous problem also, this distance was B. This was fixed. This was fixed here. Because this was fixed, this was fixed. Means I mean to say this is fixed. Now here this distance will be fixed. Okay, any distance you can consider that is fixed. Now we have two cable one or cable 2. You can consider two cables, cable 1 and cable 2. Okay. Now or maybe cable A and cable B. That is also fine. So cable A, this cable A length is LA equal to this length, this is YA plus YD plus here YD plus some constant. So somebody can write YA plus 2YD plus constant, some constant. Okay. For this B, somebody can write this LB equal to YB plus YC plus this one YC minus YD. So this is done, this is done, this is done, YD plus some constant, some extra. We are not considering that, some portions. Okay, this is constant, this is also constant. Don't subtract and cancel out this constant. Okay, this is constant, this is constant 1 and this is some other constant 2. Don't subtract and cancel out. Okay, so this way we can get basically this value is YB, LB equal to YB plus YC, actually 2YC minus YD plus some constant. Now if somebody want to do the derivative, as length is same, so you can write this way, YA dot plus 2YD dot equal to 0. Just a minute. Just a minute. Okay. Just a minute. We are here. So YA plus 2YD equal to 0. Sorry, YA dot plus 2YD dot equal to 0. Then other one is sorry. So once again, if you do the derivative, then you will be getting YA double dot accelerations 2YD double dot equal to 0. For B, it is YB dot plus 2YC dot minus YD dot equal to 0. Another derivative, this will be 0. Now here 2 unknown, 3, let me check. Here what this is YA is unknown, YB, YC and YD. These are the 4 unknowns. Okay, these are the 4 unknowns. B, C, D. Okay, 1, 2, 3. Okay, Now you can work with these 4 unknowns to get some other relationship also. But you know this equal to basically VA, this so B equal to VB. That way you can write the velocity relationship. Now somebody can cancel out some of the terms and we could have some other forms like this, and maybe somebody can have some relationship. And if you see carefully, the relationship is mainly governed by this type of relationship. Some velocity, accelerations, okay, that's all. Now problem sheet 5, 2.9. So what I have covered today, 2 by 5 and 2 by 9. Problem sheet 3, problem sheet 5. Next day we did I think 2.1, 2 by 2, problem sheet 1, 2 by 3, 2 by 4, problem sheet 2. Now some problem I have to solve. And let me,
Sir,
yeah.
sir, does degree of freedom always equal to number of cables present in the figure?
No. Depends upon the complexity of the problem. Not
Okay,
always, okay? Because this is very simple problem given. Many times it is complicated. It needs some time to visualize. Okay, so in coming years might be you will be knowing more and more. So for mechanics subject it is very simple. You have to just look into the problems, how many parameters you want to specify the configuration, that is the degrees of freedom. Here it is free, it can move, but in static problem we have seen no, the degrees of freedom like that way we have considered. Okay. Okay, fine. Now let me show you some. We have to solve the problems. Problem sheet. Let me come back. Okay, I have given assignment 1, 2, 3 and 5 and remaining 6 onwards mid-sem syllabus, end-sem syllabus I have given everything. You can do when I'll cover these chapters, but not it will not be as the assignment. Okay, 4 to remaining 5 basically. Total 9 problem sheet, 4 I have given for dynamics, 5 is remaining, 6 onwards. Okay. Now let's come back here. I'll just show you solutions here itself. It's very simple problems. So it is given that, so for this problem 1. So what we can do for this type of problems, okay, we have to take some reference point. We have to take some reference point and you have to give some sort of length or distance wise. Say if I want to consider this one, this to this is B, correct? Maybe this is AF B and say this to this some constant, say A, and this to this so this is SA. Okay, and you can look carefully, it is fixed some similar such that here this to this, okay, and this to this some extra terms, say B. So total length, first of all you said how many degrees of freedom for this problem? Do you have how many degrees of freedom? It is only one cable. It is passing through this like this. How many degrees of freedom? Any input is required?
Sir, 1.
1.
Sir, 1.
Very good. 1. So length of the cable so that is AL equal to A plus S, here one S, another S, another S. 3SA plus SB plus B plus constant. So SA, mainly this 3 times SA and this is SB.
Sir,
Yeah.
there is a height difference between the third essay and the other two essay.
You mean to say, no, just a minute, let me change color. I'll tell you. This to this is S1. So S1 plus S1 plus S1 minus this is constant. So everything is going under the constant. Understood?
Okay, sir. I understand.
S1, S2, yes, yes. You can have here some C value, then minus C.
Minus.
That will go under constant. Okay. So this is the expression. That means L equal to 3SA plus HB plus some constant. Again, this length is fixed. It is not extensible. Fixed length. So somebody can have 0 equal to, doing the derivative, L dot equal to this equal to 3SA dot plus SB dot, or 3, this SA is nothing but VA plus 3VB equal to 0. Now why one is positive, other is negative, you can understood. When you are moving this B rightward directions, this will move in upward direction. This is your understanding. So what the way you can write? Say B is moving right and A is moving up. Then this positive negative options will be understood. How it will be understood, I'll tell you. Why positive negative? Say the B is moving in these directions. Then this SB will increase, is not it? If this B is moving right direction, this SB will increase, is not it? Length, SB will increase.
Yes, sir.
Then VB will be positive or increasing or positive. Then SA will be decreasing. Then VA will be negative. Decreasing means
Yes, sir. Yes.
that way relationship, positive and negative. Now for this problem, it is given that block B has leftward velocity. So this B equal to leftward. So it is, this leftward means this length will decrease. Let's consider minus 1.2 meter per second. Why minus? Because VB length will decrease. So I have considered this velocity will be negative. That is, it is moving leftward. My understanding, I have given as a negative. Then your VA will be, sorry, here, yeah, I did this mistake. VA will be minus VB by 3. Okay. So minus 1.2 by 3, 0.4 meter per second. It is positive now. Positive means your this positive means SA length increasing. If SA length is increasing means A moving downward. Is not it? That information you have to write. Yeah, down. So positive negative is related to that only. If you consider this concept, it's fine. That if length is increasing, you will use positive. If length is decreasing, then you will use negative. Even without positive negative also, somebody can very carefully look into this matter, and you can write which is upward and which is downward. That is also fine for me. Okay. This problem is done. Any doubt? Problem number 1? No, correct?
No, sir. No, sir.
Okay.
No,
then
sir.
we will go last
Yes, sir.
problem.
Understood, sir.
Yeah, problem 4. This one will go. Problem 4. Neglect the diameter of the small pulley. This one. Yes. Diameter of the small pulley attached to body A. Determine the magnitude of the total velocity of B in terms of velocity VA that the body A has to the right. So this is basically moving to the right, it is told. So it is, we say VA is moving right, is given, okay. Assume that pulley cable between V and the pulley remains vertical. Assume that the cable between V and the pulley remain vertical. So this will be
AB
always
is
vertical.
vertical.
Yes, yes.
Yes, sir.
And solve for a given value of x. Say x value is given. So somebody can consider this way: x given, here is given. Maybe you consider from this one direction is y. This is y, and so this is L, length L. This to this. Okay. What I want to say, the total length capital L is equal to L plus y. This is L plus y plus constant, or it is told neglect the diameter of the pulley, then remove that. This L plus y, actually y is the distance. Okay. L plus y equal to total length, is not it? See, this L plus y equal to total length of the pulley, that remains same, constant.
Yes,
Okay.
sir.
Yeah.
Yes,
So
sir.
if you do the derivative, L dot equal to small l dot plus y dot, or actually this y dot is nothing but yb, is not it? See here, y dot is yb, or let it be y dot itself equal to minus L dot. So y dot, if it is y is moving down, you can see down means it is increasing, then length will decrease. That's why y dot equal to minus L dot. Now another relationship you can get from this, L square equal to x square plus h square. This is valid. But h is constant, L is changing, x is changing. But this relationship will be always valid. L square equal to x square plus plus h square. That is valid.
Sir,
Okay.
can you please tell why y dot equal to minus L dot?
Because this was 0. This was L
Oh,
equal
yes,
to,
yes, yes.
yeah, that was 0. Sorry, I forgot. Okay. Thank you. Yeah, that was 0. So that's why it was minus. Now if I use this, so do the derivative, 2L L dot equal to 2x x dot plus 0. H is constant, this is constant. You can see from the problem. That value will not change. So 2L multiplied by L dot equal to 2x x dot. From that relationship, somebody can write that this L dot equal to x dot by small l. X dot small l. We will utilize this equal to minus x dot by small l. This is y dot. So you can see carefully that x is decreasing, L is y is increasing, x is decreasing, L is also decreasing, y is increasing. Okay. Now, if you consider the sign also positive, negative, so somebody can write this way: VA equal to minus x dot. VA is positive. Here y minus x dot minus, I have taken y to show that x dot is decreasing, so this minus will be nullified and VA is positive. I am considering this way. As x is decreasing, I have put the minus sign. Is it okay?
Yes, sir.
As x decreasing. So VA is equal to, that is the VA equal to x dot, and somebody can note that actually VAX, this is VAX along the x direction, and VAY, what is the VAY for this? VAY
0.
0, very good. That's why VA equal to minus x dot. Okay, very good. Now, what is in that way? VB,
Y dot.
VBY, that is y dot, equal to positive I told, then x by L, x dot is VA. Okay. X dot is VA. Okay. X by L multiplied by VA. Y dot is this, minus x by L, x dot, minus x dot equal to VA. So this is the VBY. What is VBX? Is there any value of VBX?
No, sir.
No, sir.
No.
You look into the problem. If this moves, this
So
block,
VX equal
Yes.
to VA.
Yes, sir.
it is
VA.
VA. Okay, very good. It is VA. Okay, that is the tricky. Okay, that is VA. That is VA means minus x dot. Fine. Now what is VB? Square root VX, sorry, VBX whole square plus VBY whole square equal to VBX square root VA square plus VBY x by L VA. Okay, this square equal to VA will be outside. So 1 plus x square plus multiplied by 1 plus x square by L square. So this is L square, 1 plus x square plus L square means L square plus x square. It was 1 plus x square by L square. So L square will be denominator, x square plus h square. So L square equal to x square plus
H
h
square.
square.
Yes,
L
sir.
square equal to this. So if you replace this, it will be 2x square plus h square by x square plus h square square root multiplied by VA. That is proved. Got it? Or should I explain once? Okay, I am telling once again. In this problem, total length of the cable is constant. So I have considered two things. One is, let's have this point to this point, this length as a y, and this to this length as a L, such that L plus y will be total cable length, that is constant. If I take the derivative L dot, that will be 0, capital L dot will be 0, that is small L dot plus y dot. So small L dot will be minus, sorry, y dot will be minus L dot. Now from the relationship L square equal to x square plus h square, taking derivative 2L L dot equal to 2x x dot. So L dot will be x dot by L. If I put that one, y dot will be minus x dot by L. Now we are considering as x is decreasing, it is negative. So VA will be minus x dot at x decreasing. So VA x will be this, Vay will be negative, sorry 0. So Vax will be minus x dot. Now for Vby, that is nothing but y dot. And y dot, this y dot value we got x by L Va. And Vx equal to Va, it is minus x dot. Now using this expression, what will be the value of Vb square root Vx square plus Vy square? Put the value, finally we will get the expression. Is it okay?
Yes, sir.
Okay. So I have solved 1 and, just a minute, I can note down 1 and 4, 2 and 3 for you. Okay. I am closing this. That is done. Now problem sheet 3. As I told, it is normal and tangential coordinate. Okay. So let me start with this first problem itself. So there is one particle P that is moving in a circular path. R equal to 3 meter radius. At the instant considered, speed of the particle is increasing at the rate of this. Speed of the particle is increasing, means AT or AN? AT 6 meter per second square, and magnitude of the total acceleration, it is A total, that is 10 meter per second square. Okay. So AN will be A total square minus AT square. Okay. So 10 square minus 6 square, you will get some value square. Okay. So AN will be square root meter per second. Determine the, now it is told that determine the speed of the particle. AN equal to B square by rho. This rho is nothing but circular path equal to R equal to 3 meter. You have to calculate velocity. That's all. So what we have utilized, that given AT value, A total value, A normal value will be, normal acceleration will be square root A total square minus A tangential square, and that is normal acceleration, centrifugal or centripetal, whenever it is required. Okay, that acceleration will be V square by rho. Rho equal to R, constant radius per circle, and you calculate the value of the V. It is over. One is done. Now maybe I'll solve problem 3. Maybe no, I can note down here, just a minute. 1 is done. Number 3. There is a basketball player is releasing a ball with the initial condition given. You see, this is the initial condition given. He is releasing the ball with some velocity V0 30 meter per second with some angle theta equal to 30 degree. Determine the radius of curvature of the trajectory just after the release and at the apex. So basically, if you release here, it will move like this and it will come back, correct? So this is the apex. This is the apex. So two cases. B is at the apex and A is just after the release. For each case, compute the time rate of change of speed. Time rate of change of speed. Compute the time rate of change of speed. Here it is B dot basically. You can see the unit, okay? It is missing. Actually, it is asking accelerations. It is asking accelerations. AT it is asking basically. You try to understand this word and also compute the time rate of change of speed. Time rate of change of speed is tangential component. Tangential component of the accelerations. Okay, it is V dot basically. Missed there. Okay. So to solve this type of problem, what we have to do, come back here. If I draw this, line, and this is the some horizontal line. Okay. Now, so this is velocity v0 30 meter per second. This is 30 degree. If you are applying the velocity, so that will be tangential directions or normal directions. In normal and tangential coordinate, which one you want to consider? Along this 30 meter per second, you want tangential component or normal component?
Tangential.
Tangential. So this is a T and this is N. Okay, can you tell any acceleration is acting on that or not? Is there any acceleration acting?
Yes.
Which one?
Yes. Gravity.
Gravity. Very good. So we have, this is the gravity. So what I want to do, I want to decompose this gravity into two parts. I am not showing this one, I am showing directly this part. Very good. So this part. This is one, another one is this. And this is 30 degrees, so this also will be 30 degrees. So it will be G sine or cosine? Cosine 30 degree. G sine 30 degree. Okay. And G equal to 9.81 meter per second square. So what is AN? Tell me, what is AN value?
G cos 30.
G cos 30. And AN equal to V square by rho. Okay. V square by rho, then V you know, you can calculate the value of rho. Actually this is rho, okay, not P. So AN will be here, let me check, I don't have the value here. So rho will be finally, rho will be V square by AN, V square by AN means 30 square by AN is 9.81 multiplied by cos 30 degree. You will get like around 106 meter. So you have calculated that one. So what is AT? Tangential AT?
G sin 30.
G sin 30. Okay. You want to use positive or negative?
The negative, opposite direction to the velocity.
So G sin 30. You put the value whatever you will get. I think minus 4.91 meter per second square. Now for the apex, it was like this. Okay. So this was normal, this was tangential. Okay. So along this you have acceleration G and your velocity was here. It was basically, this velocity was
Zero.
how much?
0.
It will be 0. Why it will be 0?
So it will be V cos 30.
B cos 30. Okay. No, here no. Yes. Okay. You told one thing, that is correct. Actually, Vy will be 0. Okay. And Vx will be
V cos 30.
cosine 30. Very good. Vy will be 0 and Vx will be this. And what will be AT? See,
0.
An equal to G,
0,
AT will be 0. Yeah. That's why it has been asked. Let me check what it has been asked. Radius of curvature. Okay. So what is the radius of curvature for this case?
V square upon G.
Correct. So this AN equal to G equal to V square by rho. You utilize this expression, okay? You will get the rho value. And rate of change, and compute the rate of change of speed, that is AT, that is 0. Okay? That is AT, that is 0. Is this clear, this problem, or should I repeat?
Yes, sir.
Yes, done. Now another problem. Let me, yes, this problem. We solve this problem 5. There is a race car A, actually two race car A and B. A follows the path AA. This is the A. It is following this path. And B is following BB path. Be careful for this one, for BB path, and AA path. There are two paths, as I told. Radius of curvature is different. One is 77, other is 82. 88. One is 88, other is 72. 88 is for A and 72 is for B. This is for B. And 88 for A. And it is told that each car is having constant speed, V equal to constant, not changing, okay? But limited to that, corresponding to the lateral or normal acceleration of this 0.8 g, AN normal, 0.8 multiplied by g. G is acceleration due to gravity. It has been told. And we know this is V square by rho. That means V equal to square root 0.8 G multiplied by rho. This expression we want to utilize. Now for VA, for A, as I told, for A, this color 88 equal to square root 0.8 multiplied by 9.81 multiplied by 88. You will be getting 26.3 meter per second. VA. Similarly, VB will be say 23.8 meter per second. So speed of A is higher than the speed of B maximum, because it is told the square root rho, radius of curvature was more for A, so hence its speed also will be more for A. Now for SAA, total distance A will cover how much? This A, this color, how much distance it will cover for the race? And it is told that determine the times T and TB for both cars to negotiate terms as delimited by the line CC. This is the line, final destination. It will start here, it is the final destination. So what is the distance A will travel?
72 pi plus this
Okay,
distance also
I will erase this, you will understand better way. Now tell me, A is, this is
Pi
A.
88 pi plus
Pi multiplied by 88. Anything is plus? You try
No,
to
sir,
understand.
2 times.
This is the center. No, this is the center.
No.
No. Then
sir, 88
SBB will be pi multiplied by 72 plus how much?
16.
32. 16 down and 16 up.
So 2
Yes.
multiplied by
30.
60. Yeah. So you will get some value. Okay. Now you calculate CA equal to SA by VA and TB equal to SBB by BB, and it is around 10.52 second and it is 10.86 second. Okay, B is taking more time. B is taking more time. Why? Is it only why B is taking more time? Tell me. A is taking less time. Why? There are two reasons basically. One is its velocity is more. VA is greater than VB. Other thing is B is traveling more than the A. Is that it? B is traveling more than the A.
Yes, sir.
I believe from the graph. Okay. You can see the distance travel like this fellow. 1 minute. This is A, correct? Yeah. This fellow is traveling only this distance. Simple path. So, okay. Pi r, and this fellow is traveling this distance. So graph or schematic diagram is also saying that some distance will be more travel. Okay, if you calculate, you will get this value. You can get the idea. Okay, fine. That's all. So problem. I want to note it down. This is number 5. 5 is done. So for problem sheet 5, 2, 3 left, and for this 1, 4 and 6 left. Okay. You do the remaining things. Now tell me, for problem sheet 1 and 2, what are the problems you are facing difficulties?
Sir, in problem sheet
Yes,
1,
sir.
the answer of question number 3 is not
Okay.
matching.
One thing I missed. Just a minute. One thing I missed. Some data was missing. Just a minute. Forgot to tell. There is one problem. One data was missing. Okay. So you can note down, or else you will not able to get the correct answer. This problem 3, this here it is missing is this one, VB equal to 2 meter per second. This is missing. You note down. Problem sheet 5, VB, problem number 3, 5 by 3, this problem, VB equal to 2 meter per second square. That was missed by mistake. Yeah, now tell me.
Sir, in problem sheet 1, question number 3, the answer is not matching.
This one.
Yes,
Okay.
sir.
Okay, let me
Yes,
check.
sir.
Yeah. Just a minute. This one. Let me check.
Yes, sir.
So for this problem, problem 3, you mute yourself. Okay. I'm getting some sound. Yeah. So the answer is not missing. Let me check. So it is given V equal to 5s power 3 by 2.
Yes.
Okay. So what is S is in
Here
millimeter.
S is 12, sir, but the answer coming is from S is equal to 2.
Yes, sir.
Okay. Okay. So that means this is the mistake. Okay. Sorry. This is 2. Fine. Okay. It was
Yeah,
missed
okay.
by mistake. Fine. Very good. So that's it. That is done. I missed. Actually, previously it was we are using, but I forgot to change it. It is 2. Okay. 2 millimeter only. Next. Yeah.
8, sir. Question number 8.
Question number
Problem 8.
8. Okay. Anything else apart from 8? Problem 1. Anybody
No,
can
sir.
tell. 8 only, correct? 8. Okay. Okay. And now let me check problem sheet 2. Anybody can say any problems you are facing, or what are the problems you are facing? Problem 2.
Sir, we have not done.
Okay,
Yes, sir,
fine.
we haven't done it yet.
Okay, fine. See,
Yes,
I
sir.
will
We
tell
couldn't
you.
have done problem.
Okay,
Yeah,
okay,
not
fine.
intended.
What I am telling, I have one serious issue here. Actually, as I told, from 21st onwards, you will be in the institute, so offline class. Now, if I take this 15 at the class test, this today problem sheet 1, 2, 3, 4. Maybe I can solve another 3 problems today. Okay, then I think only problem sheet 5. There are 2 problems remaining. For problem sheet 3, 1, 4, and 6 problems remaining. And today I am solving now say problem sheet 1, problem 8. Okay. Then remaining 4, 5 problems easily we can solve by next Tuesday. Is not it? If you are working, then I can solve remaining things. We can together solve remaining things, but by 8 itself. If it
Yes,
is
sir.
so, then 11th, if I start new chapters, kinetics, you will be in trouble you will be in a bad shape to give the exam here, 15. So why not we can take that exam on, you can give the exam on 11th itself. You just think such that on 15th onwards, I can start kinematic 1 day, 2 day, 3, 4 days I will get. Understood? If you can give the exam here, it will be better for you. Time management issues. I can take 15, 22, 25 and 29. 1, 2, 3, 4, even 1. This will be the revisions. So 1, 2, 3, 4. These 4 chapters I can in 4 days I can complete. I can complete 5 chapters. Is it possible to give the exam class test on next Friday? You think? And
Okay,
tell
sir.
me. Then it will save some time for you also. And what I can do, 1 hour I will take the exam, and after the exam, okay, I will show you the answer script for midterm, because we will not get any time after that. Although you will be coming to the institute, but it is not recommended to interact in my cabin. Students will come, many students. It is not good idea. Classroom is okay. So if we can give the class test on 11th, I can show you answer script for the mid semester after the class test. 1 hour maximum class test will be there. Understood?
Sir, actually, I
Yeah.
think it would be little bit difficult for us to give on 11. I mean, sir, actually, next week we have a lot of assignments and tests. That is why I think so.
Okay. Next week, lots of. Okay, fine. Then let it be 15 itself. No issue. Okay. Or another options. Some maybe I can take in that case. 15 will be risky for me. Why? Let me just a minute. 1, 2. I need to complete the syllabus also. 1, 2. Then give offline test after 21st. 15 I cannot do. I cannot take the class test because time I'll not able to manage. Okay. I cannot take on 15. Then some chapters I will explain here. Then one will be gap. Then holies. Then I will be in a trouble. So what I'll do?
Sir, then we'll try to give on 11th only.
Okay.
Yes, sir.
Okay, fine. Then fine. Okay. Now concentrate on here. What problem you told? So you 11th will be the class test. Then the answer script also I can show you mid semester. This problem. Okay. This is very tricky problem basically. So there is one preliminary design. This is the preliminary design for a rapid transit systems calls for a for the train velocity to vary with time as shown in the plot, as the train runs with 32 km, 3.2 km actually, sorry, not 32, 3.2 km the distance between station A and B. The slope of the qubit transition curves, which are in the form of this, are 0 at the ends. So the slope of the qubit transition curves. Okay, this is the qubit function. Okay, so if this is the graph, this is velocity. Okay, and this is time. This is 15 seconds, delta t, 15 seconds, and you can see curve is looking symmetric. These sections and these sections are symmetric. And this function is given for this only. What is the functions? I can write a plus bt plus ct square plus d t cube. So you tell me, what is this slope? Basically, it is representing what? Velocity, acceleration, what it is, or distance. This slope is representing. Sorry, this this graph is this equation is representing what? You try to understand. Slope of the cubic transitions curves, which are in the form of this, are 0 at the both ends. Now tell me, then this expression is for the slope of the curve, or it is the representation of cubic transition curve? Which one? It is representing velocity or slope of the velocity? A plus bt plus ct square plus dt cube, or distance? You tell me that one first. What do you understand? The slope of slope of the cubic transition curve, which are in the form of this. Then this is representing slope of the curve, like here it is v versus t curve, v versus t, velocity versus time. So it is representing this one. It is slope of the curve, or that is velocity, or slope of the velocity? Tell me that one.
Slope of the velocity.
Slope of the velocity. Try to understand. Slope of the velocity, the slope of the cubic transition curves are 0 at both ends. The slope of the cubic transition curves are 0 at both ends. That I understood. But which are in the form of this? What does it mean? It is representing curve or slope? This word?
Curve.
Curve. Curve means velocity or acceleration?
Velocity.
Velocity. So this is the velocity curve. Now you look into this one, some important observations. When t equal to 0, what is the velocity?
A.
Huh?
0.
0. This is observation 1. Boundary condition. 2. When t equal to 0, what is the acceleration? Any idea?
0.
Why?
0. Slopes at the ends.
Exactly.
0.
That is dv dt. That is 0. Yes. Very good. Then number 3. Velocity at 15. Time 15. How much?
0.
Velocity at time 15. This is the time 15.
130 km per hour.
130 km per hour. Okay. Number 4. Acceleration at 15. How much here?
0, sir.
0.
0, sir.
Slope dv dt at t equal to 15. That is 0. So what we understood, we are using this concept. Y, x, this is theta, dy dx equal to tan theta. That is the slope we are utilizing this. Very good. So we will utilize these four boundary conditions to simplify this. So, okay, first of all, I will try with, okay, velocity at 0, how much? Time 0, velocity? This one, correct?
0, sir. 0.
That will give this expression a equal to
0.
0. Yes. Now, next one is a 0 acceleration. If I go for acceleration, okay, some options, velocity is given. Let me write, then v equal to bt plus ct square plus dt cube. So dv dt equal to acceleration equal to v plus 2ct plus 3d t square. Now you tell, acceleration at 0, t equal, this is t equal to 0, that is 0,
Yes,
D
sir.
0.
then d equal to 0. Okay, then finally we are having v equal to ct square plus dt cube. This, up to this we understood. Now if I use that accelerations at 15, here what is the acceleration at 15? We told this is also 0.
0.
Yeah, if it is 0, okay, if v equal to 0 I already told, then I can write here acceleration equal to 2ct plus 3d t square. Now this one we want to utilize, 2 multiplied by c multiplied by 15 plus 3 multiplied by d multiplied by 15 square equal to 0. Okay, so maybe we can write 30c plus 675 d equal to 0. Let's have one expression. We are just trying to find out the expression value of c and d. So c and d we got. Now we will utilize V15. What is the V15? Here 130 kilometers per hour.
130.
So 130,000 by 3600 meter per second. Okay, so you will get some value. Now using that, if you use that, then it will be P means C 15 square plus D 15 cube. Some value will get this expression 2. This is expression 2. Now there are 1 and 2 equations, 2 unknown. C, somebody can write 0.481, D equal to minus 0.0214. Can you tell me unit of C and D? What will be unit of C? What will be unit of C?
Meter per second cube.
Yes, sir. Meter per second cube.
And this one, very good. This D
Meter is
Meter per-
minus 4.
is for, very good. So we'll write this one, meter per s cube. If you are not writing, so 3 times if you miss, 3 marks will be deducted. Okay, 1 mark for each unit minimum. Then we can write finally v equal to velocity equal to 0.481 t square minus 0.0214 t cube, and that is valid for t 0 to 15. 0 to 15. Understood? 0 to 15 we got the value of C and D, and velocity expression is this. Now we have to calculate What is the distance traveled for S? For S, when T is this. Why I am writing? Because this to this it is not valid. This case S will be 0 to T 0.481 T square minus 0.0214 T cube dt. Okay. So you will get some expression and you write here S15 you will be getting 270.8 meter. Some millimeter decimal point issue may be there, don't worry. So S15 you can get S15. Whatever S15 here also it will be same. Total distance is 3.2 kilometer. So this minus 2 multiplied by 270.8. This distance is basically from maybe A, B, correct? You write C and D. CD distance will be this. CD distance will be this, and this is around 2658 meter. So this is the distance, and the speed is constant, velocity is v. Then this delta t will be 2658 by velocity 130 divided by directly we can write that conversions 3.6. So you can get this time. Time will be 73.62 second. This time. So total time will be 73.62 plus 2 multiplied by 15. Okay. Why I have multiplied here 2? Because these are symmetric, same distance travel. So if you add this one, total time will be 103.62 seconds. So total time we got. Now this is the total time. Now what we understood, velocity expression we got. Velocity expression we got. So acceleration is dv dt. If we utilize that expression from this, so that will be 0.963 t minus 0.03 t square, 0642 t square. Once again do the integrations. dA dt equal to 0.963 minus 0.1284 t. Now for maximum accelerations, or do one thing, d square a dt square equal to minus 0.1284. So for maximum accelerations you put dA dt equal to 0, this one equal to 0, then you will get t equal to 7.5 seconds. When t equal to 7.5 seconds, to get dA dt 0, maximum acceleration or minimum. Why it is maximum? Because d square a dt square is negative. So a will be maximum. So what will be a max? Whatever a value you got here, this expression you write t equal to 7.5, what will be a value, and you will be getting 3.61 meter per second square. I am explaining once again. First of all, we understood this cubic formula is for velocity. I want to use 4 boundary conditions. At t equal to 0, velocity 0. At t equal to 0, acceleration equal to dv dt 0, because it is told that slopes of the cubic transition curves are 0 at end points. That means it was 0 both at A and both at B. that expression, then velocity at time 15 it is 130 kilometer per hour. Somebody can convert meter to second. Then next one was acceleration at 15, t equal to 15 equal to 0, slope was 0. So utilizing this we got a equal to 0, b equal to 0, and c and d we have calculated. C value with proper unit we have written here, d value proper unit we have written, that is the velocity. So acceleration dv dt, acceleration a, dA dt equal to 0 to get maximum or minimum value of a, d2 a dt square less than 0, we will confirm that that value is correspond to a maximum, and corresponding dA dt equal to 0 for a maximum a, time equal to 7.5 meter, second. Then that corresponding a value from the expression you can get 3.61 meter per second square. Now another question it has been asked, the total time. For the calculation of the total time, what we can do, that we can utilize some basic concept, that once you know this expression s value, by doing the integration you can get this s value for s15. If I put that in expression, we can get some value is around 270.8 meter, this distance. If this is the distance, so here also same distance will be traveled. So 2 multiplied by 270.8, that has to be subtracted from 3200 to get this delta t, distance traveled with uniform velocity 130 kilometer per hour. So we can get the time required. So this 15 second, and this second time, total time traveled. That's all. Have you understood this problem now? Should I explain?
Yes, sir. Understood.
Okay, understood. Let's come back. So what I have understood, that in rectilinear motion, problem sheet 1, you have solved everything. So remaining problems, next day I can give you hints, I can explain, but my request is, be serious, only read these sections like 2.2, 2.1, 2.3, 2.5, that way, and be ready for the class test, also for the end semester. So your task will be, go through the books carefully, quickly, then start solving the problem. Next day, whatever the problems you are facing the issue, if I require, I will give some extra time to finish it up. Till now, as per my understanding, problem sheet 5, there are only 2 problems remaining. Problem sheet 3, only 3 problems remaining, and problem sheet 1, I believe everybody has solved all problems. So in problem sheet 2, there are only 6 problems. 1 problem I told on that day. As a whole, 24 problems for your class test 2. I believe you have hardly 8 to 9 problems left. Next day, in this weekend, you try these 8 problems, and if you are facing some issue, then next week I will give you hints. If required, I will give some extra time. That's all. But please, my suggestion is, please you study this and try to finish it up. Otherwise, in end sem, everything will create problems, all subjects, not only me. Your teachers are here to create disturbance for you. That way you will consider. Don't do that. Okay. Okay, guys. Now attendance, please. 1 minute. Quickly, I have to take the attendance. Okay. 25 present, 26, 27, 28, 29, 30 present. Then civil 77 present, 78 absent, 79 present, 80 present, 81 absent, 82 present. Then 83 present, 84 present, 85, 86, 87, 88, 89, 90, 91. 92 absent, 93 absent, 94 present, 95 present. Then CST 58 is absent, 59 absent, 60 absent, 61 they are 60, 2 present, 63 is absent, 64, 65, 66, 66, 67, 68, 69, 70 present. Then electrical 49, 50, 51, 52, 53, 54, 55, 56 is absent, 57, 58, 59 present. Then IT, electronics, sorry. 35 present, 36 is absent, 37 present, 38, 39 absent, 40 present. 41 absent, 40, 42
I was
present.
present in last class also, but I'm not
37,
absent.
37, huh?
Yes, sir.
Okay, fine, given,
Sir,
given.
actually, previous class I also present, sir. Can you mark my attendance, sir?
Yes,
Actually,
yes. Your role?
Sudipto, sir, civil 080.
Civil 8. Just a minute, just a minute. Civil, yes, marked. Okay.
Thank you, sir.
Okay. Just a minute. I am in electronics. Electronics is done. Then IT 53, 54, 55, 56, 57, 58, 59, 60 is absent. 61 present, 62 present, 63, 64 present. Then mechanical 49 absent, 50, 51, 52, 53, 54, 55, 56, 57 present, 58 absent, 50. Sorry, 58 present. 58 is also present.
Sir, I'm present and
Yeah, yeah,
58.
yeah, yeah, 59 present, 60 is absent. Just a minute. 16 is absent, 60, 25 present, 26, 27, 28, 29. Okay. Then 30 is absent, 25 absent, mining, 26 absent, 27 present, 28, 29, 28 is absent, 29 present, 30 present. Just a minute. Those who are absent, let me tell once again. Civil 81, then Civil 81, then CST 58, 59, 60. Then electrical 56, then electronics 36, then 39, then IT 60, then mechanical 60, then mining 25, 26, then uh, then last one is 20, just a minute, 28 mining. That's all. Okay. Okay, fine. So see you next day. Be ready. You spend some quality time, and whatever doubt you have, you tell me. I will help you. Okay. Next week,
Sir,
this. Yeah, yeah, yeah.
the class test is on 11th, right? And next week we have like 7 to 8 assignments pending. So if you could change those assignments into normal practice sheet, it
Which
will
one?
be
Tell me.
the all assignments
Okay,
of
okay. Don't
dynamics.
worry. Don't worry. Assignment will be delayed on that day. Don't worry. So which date do you want assignment? I am changing now itself. 20 is okay. 20.
Uh, I cannot stay on my own
Okay, okay. So other
all that.
students, what date I should give? Maybe 27 I am giving. Okay, 27. Just wait. Now itself I'll do. Otherwise I'll forget.
Okay, sir.
Okay, just
Okay, sir.
yeah, yeah. 4 assignment. I forgot regarding this. Very good questions you have told. So just hold on. Okay, 27. 27. Okay. One I have done. Yeah.
Sir, assignment, you have given assignment 3 mistakenly 100 points.
Okay, don't worry. I will not take that. Okay. Don't worry. All those things are small things for me. Okay. I have not checked that. Don't worry. One I am changing now. 10 you want. Okay. We never check this. Okay. What happened? We have all manual calculations. Update 27. Now I have changed. One is still remaining. March 27. March 27. March. Okay, all are done. So your task is now this problem sheet 1, 2, 3, and 5. This is your target to finish to solve these problems at least 2 times minimum. Then these corresponding study materials you can get from the books, and you solve this problem. If you are facing any issue next week, let me know during the class hours itself. I will give all hints, but you have to do at your own, or else if I change the questions in the final exam, you will be in a trouble. Okay. Okay, guys. Thank you for your patience. Bye. Bye. Bye.
Thank you, sir.
Yeah. Bye. Bye.
Thank you,
Thank you,
sir.
sir.
Yeah.
Thank you,
Bye.
sir.
Bye. Bye.